Drop a glass. It shatters. You have never watched broken glass rise off the floor and reassemble itself into a cup. You have never uncracked an egg. You have never seen smoke pour back into the sauce. Your gut says, obviously. That is just how things work. One direction. Always forward. Physics says, I have no idea what you're talking about. Here is the uncomfortable part. The fundamental equations governing the universe, Newton's laws, Einstein's relativity, quantum mechanics, every single one of them runs equally well in reverse. The mathematics does not distinguish yesterday from tomorrow. The rulebook of the universe contains no instruction that time must go forward. The laws are completely blind to the wall you live behind. So the direction of time, this one-way street you wake up on every single morning, is not written into physics. Something outside the equations put it there. And once you look at what that something is, calling this an accident stops feeling like science. It starts feeling like a placeholder for an answer the textbook is not allowed to finish. Time is not a river. It is a machine pretending to be a feeling, and the machine has been running at a precision that should not exist. In 1905, Albert Einstein did not just make clocks act strange. He collapsed the idea of now. Before Einstein, time was a backdrop. The same for everyone, everywhere, ticking identically, whether you were standing still or moving at extraordinary speed. Absolute, universal, obvious. Einstein said, no, time bends, and the bending follows exact mathematical rules. Speed slows time down, gravity slows time down. Not as a metaphor, physically. A clock placed on the floor of a building ticks measurably slower than an identical clock on the roof. Not by much. But physics notices even a difference of 1 foot. Raise a clock by the width of a school ruler, and modern atomic instruments detect the change. Experiments at institutions like NIST and GILA have measured time dilation across a height difference of roughly 1 millimeter, the thickness of a pencil tip. Time changed. In 1971, physicists loaded 4 cesium atomic clocks onto commercial airplanes and flew them around the world, some traveling east, some west, then brought them home and compared them to identical clocks that had stayed on the ground. When the planes landed, all the clocks disagreed, not because something broke, because they had traveled at different speeds through a flexible medium. Time itself was the medium. GPS turned this from a laboratory curiosity into daily survival. Every satellite orbiting Earth must correct its onboard clock every single day, accounting for the reduced gravity at altitude and the speed of the orbit. Without the correction, positioning errors accumulate by kilometers within hours. Engineers did not overcome time. They surrendered to it and built Einstein into the paperwork. Now here is where the story gets harder. If time bends, if it stretches differently depending on speed and gravity, if clocks 1 millimeter apart genuinely disagree, then what exactly is the present? Einstein's answer was brutal. Now is not a universal spotlight sweeping across the cosmos. It is more like a flashlight in fog. Personal, local. 2 observers moving at different speeds can disagree, not just about what they feel, but about which events are simultaneous. Which ones happened first? And both of them are right. The universe has no master clock. It never did. What it has instead is structure. A 4-dimensional fabric physicists call space-time, in which every event, every explosion, every collision, every photon launched from a dying star has permanent coordinates. Not just where it happened, when it happened, together. As a single fixed address in a map that does not refresh or update. The map is already complete. Picture a glass block filled with frozen fireworks. Every burst, every trail, every spark, suspended exactly where it was at its own moment. Move a thin sheet of light through the block, and whatever the sheet touches looks like now. Tilt the sheet from a different angle, and now means something different, but the fireworks never changed. Every moment that has ever happened is still there, frozen, permanent, pinned. Physics calls this the block universe. It is not philosophy dressed as physics. It is physics dragging philosophy into the room by the collar, sitting it down, and refusing to let it leave. For something supposedly accidental, the bookkeeping is disturbingly clean. So if every moment is permanent, If the past is not deleted but simply behind us, what put the arrow in time? What forces the direction to point one way and never the other? The answer is one word: entropy. And the number that comes with it is one of the most unsettling figures in the history of science. Entropy is disorder, the tendency of any system to drift from organized toward chaotic. Eggs shatter and do not unshatter. Rooms become messy faster than they become clean. A fact every parent has confirmed without peer review. The rule is universal. In a closed system, entropy always increases. The universe has one gear, from order toward disorder. And that one-way drive is precisely why time has a direction. Past means more ordered. Future means less. The arrow of time is, at its foundation, the arrow of mess. But here is the problem nobody likes to raise at conferences. The second law of thermodynamics tells you entropy increases from wherever the system starts. It does not tell you where the system started. It assumes a beginning. And for the arrow to have run cleanly for 14 billion years, producing stars, galaxies, planets, atomic structure, memory, and causality, the universe had to begin in a state of almost incomprehensible order. How ordered? In 1989, mathematical physicist Roger Penrose calculated the probability of the universe beginning in the specific low-entropy configuration it actually had. Not approximately, specifically. The number he arrived at, 10 to the power of 10 to the power of 123. Read that again. The exponent is not 123. The exponent is 10 raised to the 123rd power. The observable universe contains roughly 10 to the 80th atoms. Penrose's number does not merely dwarf that. It does not share a conceptual shelf with it. You could not write out its digits in full, even if every atom in the observable universe were a single digit on a page. It is a number for which we have no adequate analogy. Only inadequate ones. Imagine a cosmic roulette wheel with one slot for every possible starting configuration the universe could have had. The wheel had to land on the one specific slot that produces gradients, structure, memory, and the arrow of time. One slot, out of a field so vast that every number you have ever been asked to imagine looks like a digit on a grocery receipt. If the wheel had landed anywhere else, any other slot, any other initial state, there would be no structure, no direction, no distinction between past and future, no memory, only an undifferentiated, structureless, meaningless now, forever. This precision was not demanded by any physics equation. No force enforces it. No physical law required it. It is an initial condition that had to be in place before the system ran, configured before there was a frame to configure it in. The clock had to be wound tight before it was released, and wound to a tightness no equation predicted and no process we know of could have produced. For something with no preferences and no plan, the universe had very specific requirements for how it started. Convenient, isn't it? So what would it mean to actually control entropy, not philosophically but physically? Even a partial sustained reversal of entropy in a meaningful system would be the single most consequential capability in the history of human engineering. More transformative than nuclear fission, more fundamental than computation, the ability to hold local order against the universe's constant pressure toward chaos and hold it permanently. We have tried. Refrigeration reverses entropy locally, but only by exporting heat elsewhere. You cool your food by warming your kitchen. The universe's accounts always balance. Entropy is not destroyed. It is relocated. Quantum computers attempt to maintain information in fragile quantum states, coherent superpositions that collapse at the first contact with thermal noise. At institutions like Google and IBM, the most advanced quantum hardware can sustain coherence for fractions of a second inside shielded laboratories at temperatures colder than deep space. Then noise arrives. Disorder wins. Human overconfidence is adorable when it arrives with $1 billion grant. Landauer's principle, confirmed experimentally, establishes that erasing a single bit of information has a minimum physical energy cost. Entropy has a price at the level of information itself. Every time a computer deletes data, the universe collects a fee in heat. This is not an engineering inefficiency waiting to be fixed. It is a structural property of reality. And here is where the gap becomes humiliating rather than merely impressive. Every confirmation of time dilation, the Haffel-Keating experiment, GPS corrections, the millimeter-scale measurements at NIST, was not the discovery of a crude phenomenon that we refined. It was the discovery of a refined phenomenon that we are still struggling to match. The precision was already there, we are just catching up to the paperwork. Your heartbeat depends on electrochemical gradients that depend on molecular timing, that depends on atomic scale clocks running at exactly the rate they run. Adjust the gravitational potential across the height of your own body, and the clocks at your head disagree with the clocks at your feet. Your body works because time is precise at scales we cannot manufacture and did not design. The gap between our highest engineering achievements and the casual structural precision of the universe is not a challenge waiting to be closed. It is a statement about what kind of system we are living inside. The sky is not a ceiling, it is an archive. Every photon reaching your eye from a distant star is old news, delivered punctually, across distances we cannot cross, from a past that never actually disappeared. The universe does not delete its history. It cannot. The preservation of the past is not a feature, it is structural. The universe behaves like it was checked twice, measured 3 times, and cut once. An accident with this level of filing, this precision at every scale simultaneously, this bookkeeping across 14 billion years without a single exception. Here is what the accounting adds up to. Time is not a passive backdrop. It is a structured, calibrated 4-dimensional system in which every moment is permanent. Every direction is enforced by initial conditions of impossible specificity, and every clock in the universe, no matter how small, obeys rules precise enough to run your satellites, your chemistry, and your memory simultaneously. The arrow of time required a beginning so extraordinarily ordered that the number describing its probability has no home in mathematics. The bending of time is so mathematically exact that 14 billion years of recorded reality have not produced a single exception. Not approximately, exactly. A system this internally consistent, this precisely calibrated at every scale, this impossible to account for through any gradual, undirected process. There is a word for systems with this kind of precision baked into their starting conditions. We just are not comfortable using it for the universe itself.